Assalamu alaikum dear viewers, Shoaib Ahmed is here with the new lecture of the electrical engineering, and today's topic is the power factor. So this is the most essential topic in our electrical power engineering, which is the power factor. And before we are going to discuss the power factor, normally the power factor is defined as the cosine phi, or the phi angle between the voltage and the current is called the power factor. Now let's discuss the introduction regarding the power factor. Now electrical energy is almost generated, transmitted, distributed and utilized in terms of the alternating current. Because in Pakistan, our system is the alternating currents, and our mostly the power plants, generators and the alternators are producing the bulk amount of the electrical power that power the station in terms of the AC, alternating currents, okay? And our distribution and even transmission system is also to be, that power is to be carried with the help of the conductors through the transmission towers. That is only based on that alternating current, and our utilization devices or all the distribution systems or our loads which are installed in our home, that are all to be operated on the basis of the alternating current. Okay. So most of the loads in the power systems are inductive in nature, like the induction motors, the arc lamps, okay, and these are all the inductive loads, and which has the low lagging power factor. Now there are the three types of the loads in our electrical engineering. Number first is that resistive load, second is the inductive load, and third is that capacitive loads. Now resistive loads are like the loads in which the electrical energy is totally converted into the heat energy, and in the resistive loads there is no angle between the voltage and the current, so they are also consume the complete amount of the active power. Like the examples of the resistive loads in our homes is like our electric toaster, electric ovens and heaters. So these are all the resistive loads, and normally our power system is to be based on the inductive loads, our induction motors which are installed in our houses, and our fans, air conditioners. So these are all our inductive loads, and that has the low lagging power factor. The low lagging power factor is highly undesirable. It causes the increase in the current and resulting in the additional losses of the active power in all the elements that is to be starts from the power system station generator up to the utilization devices. So if our power factor is to be not maintained from the power stations, power generating station side and up to the utilization side, so it causes the additional power loss in our system, so that our consumed power will be lost, and obviously the consumer at the utilization point will pay the more electricity bill, and they will be penalized because of the low lagging power factor. So obviously we have to maintain the power factor to minimize the amount of the additional power losses in the conductors or in our power system that is to be starts from the power station and up to that utilization premises or the utilization power utilization. Okay. Now let's discuss the phenomena of the power factor. So power factor is the cosine phi angle between voltage and current in an AC circuit, not in the DC circuit, because in the DC circuit the resistance, the load which is always connected with the DC circuit, like here, if I am going to draw the circuit of the DC, so only a simple resistive load is connected with the DC circuit, and here this is the VDC voltage. Now if you find out the power in the terms of the DC circuit, so what will be? There is no any angle between the voltage and current, because in the DC circuit, in a DC supply, there is no any alternations. Okay, the voltage and current, both waveforms has the unidirection. Okay, so there will be no angle. If there is a no angle, so that our formula for calculating the power is that P is equal to VI. Okay, in the DC circuit, the formula for calculating the power is that the product of the voltage and current. Okay. Now, if we can define the power, is that the rate of doing work on the particular substance is called the power. Okay. And energy is another thing, which is the ability of the body of the substance to do work, which is called the electrical energy. Now, for calculating the electrical power in the DC circuit, there is no any angle between the voltage and current. Only pure resistive load is connected with the supply side. So this will be so there will be no angle. So so there will be no any cosine phi. So what will be the formula for calculating the power in the DC circuit? Is the P is equal to simple VI. Okay. Now, if we are talking about the AC circuit, so we are including the angle between the voltage and current. So that angle between the voltage and current is called the power factor. Okay. So this is the phenomenon of that. The power factor is that the cosine phi angle between voltage and current in the AC circuit, not in the DC circuit. AC circuit, because the AC sine wave has the positive and the negative half cycles. Okay. And in the DC circuit, there is only steady state waveform. So obviously, in the formula for calculating the power in the DC circuit is simple, P is equal to VI. And if we find out the power in the AC circuit, so simple by multiplying the power factor. So this is the power factor, which is the angle between the voltage and current in the AC circuit is called power factor. Now, in an AC circuit, there is generally a phase difference between the voltage and the current. Okay, voltage and the current. So the term cosine phi here. So the term that here, if we are going to find out the formula in the AC circuit, is that P is equal to VI, now including the cosine phi. Now this term cosine phi is called the power factor. Okay. Now if the circuit is inductive, the current lags behind the voltage and the power factor is called lagging power factor. Now there are the two types of our circuit, like inductive circuit and the capacitive. Means our loads is like the inductive loads and the capacitive loads and the resistive load. So when we are discussing about the inductive loads, so in the inductive load, always the voltage, okay, leads the current at the angle of the 90 degree, or the current lags behind the voltage at the angle of the 90 degree. So this type of the load, the power factor is the low lagging power factor or the lagging power factor in terms of in the case of the inductive loads. Okay. Now when we are talking about the capacitive loads, okay, so here in the capacitor, okay, in the capacitor, the current leads the voltage at the angle of the 90 degree, or voltage lags behind the current at the angle of the 90 degree. So in the capacitive circuit, the power factor is the leading power factor. So when if our system has low lagging power factor, normally we are going to connect the power factor correcting equipment parallel with at the point of common coupling with the power system, so that the system or the load which is drawn the lagging power factor from the main supply. Now the capacitor banks or other power factor correction devices that are connected in parallel with the power system with the point of the common coupling, they are supplying the leading kVARs, leading capacitive kVARs, leading reactive power, so to neutralize the effects of the lagging power, hence the power factor of the system can be improved. So we will discuss the power factor correction equipments or the components in our next lectures. Okay. Now here this is the our phasor diagram of the inductive circuit. So that here this is the inductive load, which has the voltage leads the current at the angle of our somehow phi, which is the normally 90 degree. Now see there is a voltage and current, both are not in phase to each other, means both are current and the voltage both are out of phase. Okay. Now when we are discussing the inductive resistive, so here this is the current and this is the voltage. Both are in phase to each other in the resistor. But when we are talking about our inductive in the inductive circuits, so that here the voltage leads the current at the angle of the phi. So in the capacitive circuit, the current leads the voltage and in the case of the inductive circuits, the voltage leads the current. Okay. Now consider an inductive circuit taking a lagging current from the supply voltage. So if there is an AC circuit and the inductor load is connected with the AC power supply, so here what is the reason behind it? That it draws the current, okay, it draws the current, lagging current from the main power supply, AC supply. So here the angle of the lag being is the phi. So here you can see the voltage and current, okay, both are out of phase to each other, not in phase to each other, both are out of phase to each other. So here in the phasor diagram, the circuit current can be resolved into the two perpendicular components. Now here, this circuit current is resolved into the two perpendicular components. Number first component is our I cosine of phi, which is the active component or the wattful component. Okay. And second is our I sine of phi, which is called as the watt-less component or the reactive component, as namely written over here. I cosine of phi is in phase with the voltage and current. Okay, so this will be called as our active or the wattful component, and the component I sine of phi over here, as you can see. So this is the reactive and the watt-less component. So there are the three types of the power from this lecture. Here, number one is the apparent power, which is the product of the voltage and current. This is called the apparent power. And in our electrical engineering, all the electrical machines are designed on the basis of the apparent power, because the power factor of the machines is unknown. So the product of the voltage and current is simply the power which is called as the apparent power. Normally it is denoted as the S. And second power is the consumed power or wattful power, useful power, that is to be consumed by the appliances when the circuit current is to be drawn, when the load is to be drawn, the current from the main supply. So that is called as VI cosine of phi, which is the active power, useful power or consumed power. And third is that our P is equal to VI sine of phi, which is the useless power, wattless power, which is the wattless power, and normally it is called as reactive power. Now here, now I sine of phi, which is the wattless components or the reactive power. Now this reactive component is measure of the power factor. Now in the power factor, this power, this our reactive power or reactive component of this point between voltage and current is the measure of the power factor. Now as you can see this phasor diagram, if this angle between the voltage and current is small, if this angle is small, okay, now what happened? Our power factor is going to improve. Our power factor is going to be improved. Means if the, now here I have written already that if the reactive component is small, the phase angle phi is small. If the reactive component is small, so this phase angle between voltage and current is also small. If this is also small, then the power factor of the circuit is high or improved. Now, therefore, the circuit having the small reactive component I sine of phi will have the higher power factor. If this angle between this voltage and current is the wider, is greater, then what happened? Reactive power will be high. If the reactive power will be high, then power factor will be low. Then the power factor will be low. If this angle between the voltage and current is very small, so the phase angle between this voltage and current phi is also small, so then what happened? Our reactive power is small. If the reactive power is small, then the power factor will be improved. So from this phenomena, the power factor is directly proportional to the active power. Means if the active power is increased, then what happened? Our power factor will be increased. Now it is usual in practice to attach the word lagging and the leading power factor with the numerical values like in our electrical power systems. The term leading power factor or the lagging power factor. So whenever the current lags behind the voltage or voltage leads the current at the angle of the 90 degree, okay, now and the power factor is 0.5 in the numerical value, so it will be called as 0.5 lagging power factor. And sometimes the power factor is represented in the terms of the percentage, and sometimes power factor is represented in the terms of numerical value that I have already write over here, like 0.5. That 0.5 is that if the circuit is inductive, then it will be lagging power factor. So 0.5, which is the lagging power factor. And if the circuit is the capacitive, so this will be called as the 0.5 leading power factor. So sometimes this power factor is to be denoted in terms of percentage, like 80% lagging power factor, 70% lagging power factor. So this is the power factor representations in terms of our numerical values and in terms of our percentage. So dear viewers, this was the lecture regarding the power factor introduction, that what is the power factor, and there are several definitions of the power factor. The cosine phi angle between voltage and current is called the power factor. Power factor also can be defined as cosine phi is the ratio of the resistance over impedance is called power factor, or the cosine phi is the ratio of the kW over kVA. Means the power factor is directly proportional to the active power and inversely proportional to the apparent power in our electrical power system. So this was the power factor, and that we have discussed in our today's lecture, that what is the power factor and what are the types of the powers that we have discussed, and what types of the loads which are connected with the power system we have discussed. So this was the lecture. I hope that you have enjoyed today's lecture. And this is, I hope that this lecture will be too much informative for you. And at the end, please subscribe my YouTube channel Shoaib Dayo and watch the informative videos related to the electrical engineering area. Thank you.